Hello, we are Memphis Community University, and today we are practicing some AP Calculus free response questions. Today the topic is area and volume. And let me remind you what's going on. So I have written for each topic of the AP exam, for example, particle motion, differential equations, and area and volume. I have written 10 free response questions that are based off old AP exams, but are of my original work. And I have arranged them in terms of difficulty, in my opinion. So I've gone from difficulty 1 all the way up to difficulty 10, where we slowly progress through those topics. And today we are doing difficulty number 5 for area and volume. So if you haven't caught the first 4 difficulty levels, difficulty 1 through 4, I suggest that before watching this because this sort of marks a change in these sort of questions. These are still going to be area and volume questions, still going to be cross-sections and revolutions and things like that. But in this case, this is going to be the first time in this video playlist, difficulty number 5, where we're going to be rotating around some vertical lines instead. So vertical lines, and also doing cross-sections that are perpendicular to the y-axis. That has not occurred in this series. In the series, we were only rotating around horizontal lines and doing cross-sections perpendicular to the x-axis. But of course, these sort of questions appear. So what we're going to do is we're going to explain what all of that entails in due time. So let's start this question. So this is actually not A. A is just find the area of the region. So let's change that. So here's our given. Our given is let R be this region. It's enclosed by the graph of this function and the vertical line x equals 7 and the x-axis. So this is the word area. So right now we're doing area, a bit of a warm-up question, but notice that in this question, because it is difficulty number 5, they did not provide us with a graph of the function. So what I need to do is I need to find the graph, and I would advise you to draw the picture of the graph on your own sheet of paper because it'll be easier to deal with. So I have my calculator here. This is our calculator number 3. His name is ready. I have him ready to go. Let's see if he can find this graph. So if you don't know what ln looks like, it generally looks like this. E to the x looks like this, if you can see my pen. But we can just graph him because we do have a calculator. So it's going to be second ln of x minus 3. We're going to graph. This is my graph. If you know ln's, you know that ln of 1 is 0. So it makes sense that this graph is crossing at 4. If you can see that, 1, 2, 3, 4. Just to be careful, if you want, you can definitely hit second calc. Try to not use the trace button. You would hit 0. Left bound means you just go towards the 0 until you get a little bit to the left side. Right bound means you go a little past the right side. You give Freddie a guess to help him out, and he does say that it is 4. So we're ready to draw this graph. It's not that bad. Again, it looks like this. We don't have to be super exact in this case. 2 ln of x minus 3. So it's going to look like this. And then there's a vertical line, x is equal to 7 to make this region closed off. And so this is the graph. This is definitely 4, 0. But as you're drawing the graph, if they do not provide the graph, or even if they do provide you with the graph, and they give you another function, for example, what you want to do is you want to find the intersection points immediately before you start finding area and volumes, because you'll use it eventually. And what some students have trouble with is they do not know how to find the intersection between this graph and the vertical line like x equals 7. And that's the case because when you type in something in a Freddy, for example, it says y is equal and they get confused about x is equal. But this is actually pretty easy to find this intersection point because this is the vertical line, x is equal to 7. All you have to do is just plug in 7 into the function. So when you plug in 7, you'll get 2 times ln of 4. Let's do that real quick. So menu, quit this guy. So we're going to write 2 ln of 4. Hopefully you can see that. That's ln of 7, so that's wrong. And then you get 2.7726 if you're writing it out. So again, find all this information before you get started. It does take a little bit of time, of course, because 2.777, because the calculator does take some time to plug in things and things like that. But you want to be careful to make sure you have the right points so that when you plug in these points, you do it correctly, of course. Certainly, anytime you type in the calculator, you want to be careful with negatives and things like that because typing in the calculator is certainly not trivial. There have definitely been mistakes in the past, most of them done by me. But let's get on. Now that we have the graph, we can go for the answer. in the question. So it says find the area of R. That's the same thing as the first 4 videos of this series. It's just going to be area is equal to the integral of what I call top minus bottom, the top function minus the bottom function. Here we are allowed to do a top minus bottom because notice if you draw any dx rectangle, the top of this rectangle is always this function. The bottom of this rectangle is always the x-axis, so it doesn't change at all, which allows us to do the integral of top minus bottom for this question. So what we're going to do is we're just going to locate what the top is. It's 2 times the ln of x minus 3. The bottom of the function is the x-axis, so the bottom of this rectangle is touching the x-axis, so it's going to be minus 0. We're going to not square anything. I almost squared everything, but because we're doing area is by definition the sum of the vertical distance between these 2 lines. So you're just summing very, very thin rectangles, and that will form area. So we don't have any squares, we don't have any pies. That's later on for volume. So all we have to do left is to just plug in some, put some points on these integrals, and then type it into Freddy here. But we do want to be careful because we're dealing with x's. We're going to use x coordinates in this region. So it looks like this region goes from 4 to 7. So I'm going to get Freddy out here, and let's see if Freddy can do this. So the integral from 4 to 7 of 2 ln x minus 3. If you want, you can write minus 0 here. I'm not going to because it really doesn't affect anything, of course. I only like to write it because it's top minus bottom. And then it looks like it's going to be 5.090. So not too bad of a question. Pretty easy, actually. A bit of a warm-up before the volumes. Area can be pretty tricky when you have to like choose between dy's and dx's. And that case is chosen if your function changes. So if you continue watching this video series, there will be some area questions that will be a little bit harder than that. And I encourage you to check that out. But for now, let's do volume. So before we do volume, let's redraw this picture in a rough sketch real quick. So it's 4, 0. This region is right here. So that's not the perfect vertical line, but we're going to do deal with it. And then we have 7, comma 2.7726. And this function is 2 times ln of x minus 3. So we have this function right here. This region is obviously this is supposed to be a perfectly vertical line, but I failed. But I think we'll be just okay. So this is volume by revolution. So the first thing to do is to first find what the rotation axis is. So it's the horizontal line y equals -2. That's down here. So we can sort of exaggerate it and say it's about right here. And then what you want to do is you want to choose whether to do a dx rectangle or dy rectangle. Again, for this video series, we've always chosen dx rectangles. And how you choose a rectangle is based off, you want to choose your rectangle so that it's perpendicular to the axis you're drawing. So in this case, we're going to draw a dx rectangle because we want this rectangle to be perpendicular to the rotation axis. On the back, we're actually going to have, not that back, sorry. I rewrote it right here on the separate sheet of paper. I apologize for that, but for this one, we're going to rotate it around a vertical line, so we're actually going to choose a dy rectangle, so get excited for that. But for now, let's do this common volume question. So we drew a rectangle, and now we're ready to decipher whether we have a washer in hands or do we have a disc. Well, what I do is I connect my rectangle to this rotation axis. So this line segment, I'm going to call it the connector. And what it is it represents the space in between the regions. So you can imagine that if you spin this region R around this axis, there's going to be like a cylinder that will be in the hole of it. So it's like bored through basically. And the radius of this this cylinder will be this axis right here. So this is the inner. So as you rotate it, so like all of this will be empty, and then there will be this little rectangle will be spinning around, sort of like a pipe. But if you followed this video series, then you know how to sort of draw your washer. So I like to draw a washer. I like to write the words outer and inner. This is going to be the same thing as the back or the next question. The inner I like to do first. It is going to be top minus bottom. So outer is top minus bottom and inner is top minus bottom of different things. So inner is top minus bottom, again, of just this phantom connector that is not actually there. So it's just going to be, in this case, 0 minus minus 2. So I'm going to write 0 plus 2. So it's the top of this connector, which is the line y equals 0, the x-axis. And then the bottom is going to be minus 2. So technically, this is actually top minus bottom. We can write it was actually 0 minus negative 2. But it's easier to write as 0 plus 2. The more interesting one is the outer. So the outer, remember, is the rectangle we drew combined with this phantom connector line segment as one single object, because as you rotate it around, this will be the outer radius of our solid. So what it's going to be is it's going to be top minus bottom again, but top minus bottom of different things. Top minus bottom of this entire object, which is going to be this thing right here, 2 ln of x minus 3. That's going to be the top. Minus the bottom of this axis will be minus minus 2. That is plus 2, of course. Great. So in this case, the bottom of both of these sort of objects was minus 2. So it's minus minus 2, so that we get plus 2. So if you know what you're doing, you know that if you've done these steps and you've determined what the outer and the inner radius are, you're basically done, because the formula is pi, because we're forming circles. What we're going to do is find the area of this washer basically, and then integrate them and stack up these washers to form volume. So we're going to do the area of this washer, which consists of one circle, the outer circle, so pi r squared, minus the area of the inner circle. So this is the formula for washers. So in this case, we just apply this formula, and then we can type this guy into Freddy. So we have pi. We do need to choose points. Because we have everything in terms of x's, we're just going to choose 4 and 7. And then we're going to write outer. So this is outer. So we're just going to be careful and write this all. So this is outer squared if you want, because outer is this, top minus bottom of this entire object. And then inner is just the number 2. So we're going to write minus 2 squared. Again, just be careful. It's not outer minus inner squared. It's outer squared minus inner squared, because that's the area of this washer. And we are ready to type this into Freddy. So let's see what Freddy got for us. So it looks like we were going to hit math, integral again. Hopefully you can see this. We're going to have in parentheses. Let's first put 4 and 7. So it's going to be, it looks like it's going to be 2. Oh, I apologize. It's not plus 3. It's minus 3. So just be careful. Again, this is how students make mistakes, and teachers make mistakes as well when they're typing it into these calculators. So it's going to be x minus 3. So 2 times ln of x minus 3. Close parentheses. That closes the parentheses of ln, and then we have to write plus 2, because that was minus minus 2 from the minus bottom part. And then we're going to close that parentheses, square it all. And then on the outside, we're going to write minus 2 squared. We can write 2 squared root of 4, of course, and then that should be it. And then Freddy tells me this is 30.7489, but this is actually not the answer. Remember to not forget to multiply by pi. So it's going to be times pi here, and we get 96.601. So again, this is a typical washer question. I am going to repeat myself because I like to hear myself talk, but just as a review, because the next question is also revolutions. What you do is you first determine which rectangle to draw, dx or dy. That's based off the axis. So we want it to be perpendicular. We noticed that the rectangle wasn't touching this axis, so we drew a connector line segment. Then we formed our washer. We found the inner radius by finding the top minus bottom of the connector. We found our outer radius by doing top minus bottom of the entire object, whatever you consider this object as. I call it the connector plus the rectangle as one object. And then we formed the formula, which is pi integral outer squared minus inner squared. We chose x's because we're dealing with x's, and we just typed it in our calculator. So that's it. Let's move on to the next question, which is the same region but rotated around a different axis. So this is fairly exciting. Let's redraw the picture for our benefit. So this crosses at 4, 0. This crosses at 7 and 2.7726, I believe. And then we have y is equal to 2 ln of x minus 3. So this is our region again. So here, we're actually going to be rotating around the vertical line x is equal to 2. So it's going to be not super to scale, but it's going to be this axis right here. And what we're going to do is we're going to take this region and rotate our normal r and then rotate it around this axis. So it's going to be rotating like this way. It's going to be spinning around like that, but don't have enough room for hand demonstrations. So let's get going. So again, the first thing to do is determine whether you should do a dx rectangle or dy rectangle. For the first time in this video series, as we go from difficulty number 1 to 10, we are actually drawing a dy rectangle. So how exciting. So this is a dy rectangle. So just like with the dx rectangle, I chose this dy rectangle because it's perpendicular to this line, x is equal to 2. Then what I do is I connect this rectangle to my axis. It looks like there will be some sort of connector. That means that we are dealing with a washer. But keep in mind that I like to write dy. I like to write my pi, start forming my integral before I do the outer and the inner, especially with dy's, because I want to remind myself everything has to be in terms of y's. So we will eventually do, just like this first one, we will eventually do outer squared minus inner squared. So something is going to be outer squared minus inner squared, but everything I see in this integral has to be y's. So the first thing I like to do is notice that this function is in terms of x's. I'm going to solve for x so that it's in terms of y, so I'm allowed to plug it in before I even do this washer. So I'm going to do that on the side. This one is pretty tricky because people don't know how to deal with ln's. They are pretty tricky. So let's do that on the side. So if we have y is equal to 2 ln of x minus 3, again, I'm trying to isolate x. How to do that is I need to get rid of the ln. So I'm going to raise both sides as a power of e. But before I do that, I need to first divide by 2 because e's and ln's only cancel out when the ln is isolated. So I'm going to do one quick step, divide by 2, ln of x minus 3. And then I'm going to take, I don't know the best way to describe it, but I have e, and then I'm going to raise both sides where each side is the exponent of e. So I have e and e. Why I'm doing this is, well, on this side, I'm definitely going to ey over 2. Nothing to simplify there. But why I'm doing this is that this e and ln will cancel out based off exponential and logarithm inverse properties. And we're going to be left with x minus 3. And then, again, I'm trying to isolate x. So I'm going to ey over 2 plus 3. So this is the formula I'm going to use when I do right minus left instead of top minus bottom. So now we're ready for this washer. So again, let's take this guy right here. So we're going to take inner first. Inner is just the phantom line connector that we drew that connects the rotation axis and the function. Instead of top minus bottom when you're dealing with x's, so we had top minus bottom with x's and also top minus bottom for the outer and the inner. For y's, what you do is you do right minus left instead. Because, for example, if you turn your paper here, so that this rectangle looks like a dx rectangle, you'll be doing top minus bottom. But if you notice, top minus bottom is the same thing as actually right minus left. So we are ready to do right minus left. It's going to be of this single connector line segment. Notice the right is touching this function, but I'm not going to write 2 times ln of x minus 3 because that's the thing with x's. I want to write something with y, so that's why we wrote this right here. We changed the function to be in terms of y instead of x's. So for right minus left, I'm going to put e y over 2 plus 3. So that is the right side of the function. The left is going to be this vertical line here, so it's going to be minus 2. Great. Outer is a little bit easier. It's right minus left again, but it looks like the right is going to be this function right here, which is the vertical line x is equal to 7. The left looks like it's x equals 2. So we're going to write the outer is 7 minus 2, which equals 5. Cool. So now we're ready for outer squared minus inner squared. So it looks like outer squared is 5. If you wanted to, you could actually just put 7 minus 2 and then square that. Sometimes I do that because I want to always do the same thing. But in this case, it was pretty easy to simplify. And then again, over here, we want y's in here. So we're going to write ey over 2 plus 1, it looks like. Where this is top right minus left. Great. And then one last thing to remember is that this dy, again, is pretty useful in terms of reminding me everything has to be in terms of y. So, for example, in this past question, we use x's, 4 to 7. But in this case, we are going to be using y's, 0 to 2.7726. So again, the key is really just change everything to y's when you're revolving around a vertical line, including the y-axis. So I'm going to type this in the calculator. Hopefully I don't confuse you. I'm still going to use x's as I type in the calculator because if you change all these variables to x's, the calculator really doesn't discriminate between x's and y's as long as the variables are consistent and the numbers are consistent. So I am going to use x's as I type this in because it's the default setting. So it's menu integral 0 to 2.7726 because again we're using y coordinates of this graph. And then in this integral, it looks like it's 5 squared. I can write 25. I trust myself enough to do that in my head. And then I have e. Where's e? Right here. And then in this exponent, we have x divided by 2. Again, if you want to be more careful, you can write y over 2. But the calculator doesn't discriminate based off the integration of the variable of integration. So it looks like I'm done with my typing. As long as I choose the same variable I chose, we get 39.542. But again, remember, we do have to multiply by pi. Some people put the pi in the front. That's probably a better way than I do it. But I'm going to multiply by pi at the end, and we're going to get 124.225. So this answer is 124. 124. Sorry. Got confused there for a second. And again, the number isn't very important on these free response questions. If this were a free response, 3 points would be for the integral. Sorry, 2 points would be for the integral. 1 point would be for the answer. Perhaps 1 point is for the integrand, and then 1 point is for the limits in the pi. So, for example, writing this correctly as outer squared minus inner squared gives you 1 point. Choosing the right numbers and having the pi in the front gives you a 2nd point. And then typing it in your calculator correctly would give you that 3rd point. But again, it's the same thing as we've been doing for this entire video series of pi outer squared minus inner squared, where inner is just the connector, outer is the entire object, but everything is just sideways, so everything has to be in terms of y's. Inner is right here, outer is right here, right minus left of the entire object. Rectangle and connector line segment combined. So this last question is going to be a cross-section question. So remember that in cross-sections, there are 2 givens that are important, and nothing else is, everything else is basically fluff. So we have the y-axis. So this is the first time we're using the y-axis as our perpendicular axis for cross-sections. That's the only 2 cases, either the x-axis or the y-axis. And then the shape matters. So it's a rectangle with heights that are 6 times the base. So again, what we're going to do is we're going to redraw this function. Hopefully you can see that. So we have, I don't know why I keep drawing so much negative area, because this graph doesn't, the region doesn't go above this, below the x-axis, but it's fine. So we have 2.7726. We have the function y is equal to 2 ln of x minus 3. So this is our region. So what you want to do first is you want to draw either a dx. I'm not going to call it rectangle now because the shape is rectangle, so I don't want you to be too confused. I'm going to call it dx bar. So if it says perpendicular to the x-axis, I draw the dx bar. But here, just like in this one, because we're dealing with perpendicular things to vertical lines, including the y-axis, we're going to draw a dy bar. And remember how this works is basically a rectangle will be coming out of the page. It's hard to imagine, but a rectangle is coming out of the page at each time you have a dy bar. And so it's basically like a stack of books, and you're just stacking them up, where over here the rectangle is going to be taller because the base is taller. Over here the rectangle is going to be pretty small, and you just have a stack of books, and you'll eventually form volume, where these books are infinitely thin. So the first thing I suggest doing is to draw the shape. So just a generic rectangle. Remember that there is an important side to the shape, which I consider to be the base of the shape, no matter if it's a semicircle, right isosceles triangle, square, or rectangle, which are the 4 main shapes that are on the AP exam. Feel free to watch some of our other videos for practices with more shapes. But remember that basically this base is glued to this dy bar, so it's just coming out of the page. And imagine if you cut this out, sort of tilted it up, have this base touching this, you'll have this rectangle coming out of the page. And remember that for our perpendicular to the x-axis questions, the base is going to be top minus bottom because it's the distance between, the vertical distance and the region, top minus bottom. But when you have dy's, you're going to do right minus left, similar to this question, because the length is going to be the horizontal distance in our region. So it's going to be right minus left. So let's do right minus left. Well, it looks like the right is going to be 7 because it's the line x is equal to 7. So it's 7 minus, and then the left is going to be this function. And again, it would be wrong to actually write this function 2 ln of x minus 3 because that's not actually what the left is. We want to use y's as much as possible, which is why I encourage students to draw a dy rectangle. So what we have to do is what we have to do from the previous step is change everything to be in terms of y. So we're going to change this equation just like before to e to the y over 2 plus 3. If you missed that step, what we did is we divided by 2 first, raised both sides as powers of e, and then we added 3 at the end. So instead of left minus right, I'm going to write, or instead of right minus left, where left is this thing, I'm going to actually have the thing that is in terms of y's. So it's going to be in parentheses. Be careful with the parentheses. Looks like it's going to be 7 minus y over 2 plus 3. If you want, you can simplify this. 7 minus 3, of course, is 4. So we have found the base of the shape. And why is the base of the shape so important? Well, it tells you how to find the area of the shape, and remember, we're always integrating the area of the shape. So what we need to do is, for a rectangle, we need to find the height of this rectangle in order to do base times height. Well, it looks like height is 6 times the base. So once we have the base, it's pretty easy. It's going to be 6 times this. Again, being careful with parentheses. 6 has to multiply this as well. So we are ready for the integral. It is the integral of the area of the shape, no matter what it is. In this case, it's the rectangle, so it's going to be this thing times this thing. You can express this in multiple ways, like 6 times this squared, but I'm just going to write that. Maybe let's write it like that, actually. So it's going to be 6. We can take out constants in the front if we want to. And then it's going to be this thing times this thing, which is itself. So it's going to be 4 times ey over 2 squared. So this is base, sorry, this is the base times the height. 6 times this squared. One thing to finish off is that we have to use y coordinates because, again, we're using dy's. So when we were rotating around a horizontal line, we use dx's, so that we use x coordinates 4 and 7. Just like with this volume question, we were rotating around a vertical line, so we had a dy bar, which meant we were going to be doing y coordinates on the integral. And same thing here, it'll be the same points because we're doing the y coordinates of this guy. So it's going to be 0, 2.7726. And then I'm going to type this bad boy into Freddy, and let's see what Freddy has to offer us, and then we're done. So let's practice writing the integral, the number in the front. So it'll be 6, not 66, not 66. I don't know what my brain is doing right now. Menu, integral, and then it'll be 0 to 2.7726, and then it's going to be 4 minus e. Again, I'm going to use x's even though I have y's because the calculator doesn't really care about what my variable of integration is as long as it's consistent. So I'm going to write e to the x divided by 2, and then on the outside, remember a squared. So maybe we'll write squared here. So it looks like we might need an extra parentheses in the front. Hopefully I can just insert one. That looks good. And then we're going to have a dx. Yeah, so just remember that squared because it's base times height, where base and the height were multiples of each other. Let's see what Freddy has for us. He gives us 68.169, and that is the answer. So 68.169. Remember to round to 3 places after the decimal. Sig figs do not matter on this exam. So let me just briefly go over this question. Again, this one is not actually that much harder than difficulty 1 through 4. What we added basically was going around vertical lines and also cross sections that were perpendicular to the y-axis. Sorry, my mouth is getting pretty dry. But so let's rush through this. So area, not too bad. Integral of top minus bottom. Volume question, also not that bad. Decided that we should do a dx rectangle because it's perpendicular to this line. Connected it by this connection. That means we have a washer. Inner is top minus bottom of this connector that we drew. Outer is top minus bottom of this connector plus the rectangle or the bar thing. So top minus bottom. And then we always form the formula pi outer squared minus inner squared. And we use x's 4 to 7 because we're dealing with x's. The new thing was converting everything to y's. So why did we have to do that? Well, we were rotating around a vertical line instead. Where's my pen so I can point to things? I've lost my pen. Okay, great. So we were doing a vertical line instead. So everything is going to be y's instead. So this vertical line's right here. We connected. This is going to be my inner, right minus left instead of top minus bottom because we're dealing with y's. And then it's right minus left of this little object right here. But the important thing is when we were doing right minus left, we want everything to be in terms of y's. So what we did is we took this equation and solved for, to solve this equation to be in terms of y's. Then we formed our normal formula, outer squared minus inner squared, where outer is right minus left of the entire object, inner is right minus left of the connector. We remembered our pi, and then we also chose y coordinates instead of x coordinates because everything has to be in terms of y's. These sort of objects range from the bottommost y, which is 0, all the way up to the topmost, which is 2.7726. Same thing with cross sections, perpendicular to the y-axis, forced us to draw this dy rectangle. Our cross section was a rectangle in this case. So the base is always the most important thing. In this case, it's right minus left. Again, you have to change everything to be in terms of y's. So we did right minus left. The base, the height happened to be 6 times the base, not too bad. And then we integrated the area of the shape with remembering that we should go to y coordinates because everything has to be in terms of y's. So if you continue all along with this video series, you'll see that these questions are probably the most common area and volume questions where you do a area question, then you do a rotation question, and maybe another rotation question, and then a cross-section question, where each time you do a rotation question or a cross-section question, you might have to change to y, so just be wary of that. It's not actually too bad. I certainly would prefer to keep everything in x's because you don't have to change those difficult ln functions to e's or maybe square roots to squares and things like that, but it's not too bad in the end, the hardest step being algebra. So I hope that you have enjoyed this video and you have gotten something out of it. Please join us when we do difficulty number 6 as we practice again area and volumes for the second half of this video series, because now we are officially done with the first 5 videos. So the second half will be the more difficult half, difficulty 6 through 10. But I believe in us, so I can't wait to do it. I will see you there when the time comes. Thanks very much for watching.